Welcome to the how-to video for determining the limiting factor, or limiting reagent. And in this case, I like to use the analogy as we're making a grilled cheese sandwich. And in a grilled cheese sandwich, we know that we need 2 pieces of bread. We also need 1 piece of cheese, and that's going to allow us to make 1 cheese sandwich. And so if we were trying to figure out how many cheese sandwiches we could make and what was the limiting factor here, we would basically just count it up, right? So 1 piece of bread, 2 pieces of bread, 1 piece of cheese. That's 1 sandwich. We could then do that again. 2 pieces of bread, 1 piece of cheese. 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 We ran out of bread. Well, if we ran out of bread, but we still have 2 pieces of cheese remaining, that means that really we're left over with cheese. And so this ends up telling us that what we have is that bread is the limiting reagent. It is the one that we have the least of. We ran out of it. Whereas the cheese, we still have 2 slices of cheese left over. It is the excess reactant or excess reagent. That's really all we're doing here. When we look at a chemical reaction, we're trying to see how much we have initially and which one is going to limit how much we can make overall. And so in a chemical reaction, we would define the limiting reactant is the amount, it determines the amount of product formed, determines how many cheese sandwiches we can make. An excess reactant is the reagent in excess, or how much is left over. And so we could think about a reaction here where we have 2 hydrogen gas plus 1 oxygen gas to form 2 water as a gas. So if we started out with 10 hydrogen gas molecules and 7 oxygen gas molecules, and we know it takes 2 molecules of hydrogen gas and 1 molecule of hydrogen gas to make 2 molecules of water. Well, as we start combining these in the same manner, right, we would say that we need to take our 2 hydrogen gas molecules and 1 oxygen gas to make a water. We can then do that again, where we take 2 hydrogen gas molecules and 1 water. We take 2 hydrogen gas and 1 water. 2 hydrogen gas and 1 water, or 1 oxygen. 2 hydrogen gas and 1 oxygen. And what we see is that we're now left over with 2 oxygen gas molecules. Thus, when we go to look at what we produced, we see that we end up producing 10 water molecules, but we still have these 2 oxygen gas molecules left over. And so in that case, we say our excess reactant is oxygen gas, and our limiting reactant is hydrogen gas, because if we had more hydrogen gas available, we could make more water molecules. But we also defined earlier that we could discuss this balanced chemical reaction in terms of moles, where this really means 2 moles of hydrogen gas plus 1 mole of oxygen gas gives 2 moles of water as a gas. And so initially, instead of 10 molecules of water, what if we had 10 moles? And we had 7 moles of oxygen gas. Well, initially, we haven't made any product. And then we start to use up some of that. Well, how much did we use? Well, let's say that we used up all of our hydrogen gas, which means that for every 2 of these, we use 1 oxygen gas, and that's going to produce a total of 10 water molecules. Well, that means that we've used up all of our hydrogen gas. We still have hydrogen gas or oxygen gas left over, and we produce 10 water molecules. Thus, our excess reactant is going to be oxygen, and our limiting reactant is hydrogen gas. We just now looked at it in terms of moles. That is how to determine limiting reactants.